Good morning, everyone. Good morning. Thank you. Good morning, everybody on YouTube. Happy Friday. I appreciate you joining us today. My name is Hunter Hardesty. I'm with Gascoigne Associates. I've been with them a little over 10 years now. We're a water and wastewater manufacturers representative. We represent over 65 different lines from screens, flow meters, samplers, you name it. Today I've got my good friend Jason with me from CPEX. They make progressive cavity style pumps as well as some other technologies here. Today he's going to talk about maintenance and ease of access and overall technology in general. If you have any questions, please feel free to raise your hand, chime in. I'm not sure what the process is on YouTube, but do whatever you need to do on there as well, and we'll be sure to address them. So without further ado, I'll pass it over to Jason.
Thank you, Hunter. And special thanks to Greater Peoria Sanitary District for having us today here on this happy Friday. My name is Jason McPeak. I do work for a PC pump manufacturer. Today we're just going to talk about some of the different technologies out there within the PC pump industry. PC pump, meaning a progressive cavity pump, has a special place in the water and wastewater municipal industry. They are used in industrial fields, oil and gas, food and beverage, you name it. PC pumps and PC pump technology is in pretty much every industry out there. So here in the municipal world, what we're going to talk about is PC pump maintenance and some of the maintain in place options that are available, some of the new technologies available, specifically regarding the CPEX variant. There are several manufacturers out there, but I'm going to go over this SCT model here and kind of give you the differences on a conventional PC pump and the SCT or smart conveying technology.
Quick show of hands before we get started. Is anybody familiar with progressive cavity style pumps at all or have any at their plant? Cool, got plans, okay.
Yeah.
Just curious.
Nice. So again, we're basically going to go through the PC pump. The pump has a driver or a motor, some means of operating the wet end of the pump. Believe it or not, that can be a gasoline engine, but more commonly and most frequently here in the municipal world, it's going to be a 460, 480 volt motor, three-phase motor, all the way down to a little DC brushed motor, say on a polymer makedown unit. The first thing and foremost, when you receive a piece of equipment, you're going to, familiarize yourself with the O&M manual. Specifically the maintenance lubrication schedules. This is an example here of one of those schedules. So packing in regards to sealing or packing. So you may have a mechanical seal. PC pumps have one seal or one sets of packing. I know that there's other technologies out there that have 2 and 4, say a rotary lobe. So you will have a set of packing or mechanical seal that does require some type of maintenance or check per se. And then, for example, packing, you're going to check the leakage rate. Packing is actually designed to drip 1 to 3 times per minute. Otherwise, the shaft is not being lubricated. So if we go and we crank the packing down, even on a vertical turbine, to where it doesn't leak at all, depending on the head, the pressure. We may be submitting that shaft to forces such as a brake pad, and it's eventually going to wear or polish the shaft beyond reasonable means.
There'll be a test on this at the end as well, so make sure you study this.
Yes.
Right?
So flushing fluid, you may have a plan 53A or B. You may have some type of flush plan on your mechanical seal. On these PC pumps, we use a single mechanical GA seal 90% of the time. We do offer back-to-back, different seal arrangements, different pressures, designed for different viscosities. And you may have a quench fluid to keep those seal faces cool. For example, if you're pumping, something, maybe sodium hypochlorite, 12.5% bleach, you may want to make sure that the backside, that stationary seal is wetted with a quench just to keep it cool during operation. So that quench fluid, say whatever it may be, you may need to check the fluid level weekly. Pump performance, check flow and pressure weekly, replace stator, rotor as required, adjust retentioning segments if required or equipped. Now, this is where we're going to get into the differences between the conventional stator and an adjustable or maintain in place, repair in place type stator. So keep in mind those can be a little bit different. Obviously with the maintain in place technology you have, it's going to be much easier. So we'll get into that here shortly. But get down through this list here. Bearings, you may have an NS style pump where you have a coupling in between. It's not close coupled, so it does require alignment. You're going to have additional bearings for that. If you have a close coupled unit, there's going to be bearings in the electrical motor, inner and outer normally. There's going to be a few bearing sets or races inside the gearbox. But other than that, there are no ancillary bearings or bearing frames. That's one of the benefits about the close coupled design is it is what it is, right? So it could be a C-face flange to flange, and then wet in flange to flange off of the suction casing. So there's no alignment required. You can just drop the pump in place and fire it up. Universal joints. There's different designs and styles. Most frequently, the cardan joint or pin joint is going to be used. Have seen gear joints, heavy duty cardan, double cardan, such as on a PTO or something like that, or a CV type joint. So we use a standard pin joint. It should operate the life of the pump. And I'm going to get into why we don't break into the joints with this type of technology, because you could be possibly opening yourself up to failure if the joint is not rebuilt correctly. So we're just going to say 10,000 hours. We can even warranty that for such, because as long as the pump's not cavitating, the joint should last the lifetime of the pump.
And we'll take this apart here shortly and pass it around and show you guys the ease of maintenance. That's the main key of this specific product here, as opposed to having to pull it out horizontally with similar projects or products. This one you actually bolt apart here and it comes this way. So it's a lot easier to work on things. You've got a lot more space. If the engineer didn't design for space in the room you're working in, you don't have to worry about being stuck in a corner or something crazy like that. So you'll see once we get to that point.
Yep. Last two here, motor, check RPM, amperage, fan covers for obstructions. That's normal stuff. I get a lot of technical questions from engineers and operators, and they say, how slow can I run this pump? And generally speaking, just across the board, me being an electrician as one of my past life, as long as we're running the motor fast enough that the coupled fan can cool the motor, which is generally a 10-to-1 turn down, 60 hertz to 6 hertz. So if we run below 6 hertz, we may need an externally powered or water cooled jacket on the electric motor. So that's just something to keep in mind there. When it comes to RPM, one of the inherent technologies of this pump, one of the inherent features of this pump is the flow curve, and I'm going to get into that here probably in the next slide or two. So yeah, if we have a linear flow curve, depending on the head, compared to say a centrifugal pump, where that curve just kind of falls off as more pressure is on the discharge side, it's kind of hard to figure out what the flow is without a flow meter. But with this type of technology, if we know the motor RPM and we know the gear ratio, we're going to know within 1% how many gallons a minute, how many gallons per hour that we're actually flowing. So that is one of the nice features of this technology, this PC pump, conventional or maintain in place, is that they say all PC pumps are metering pumps. That's simply because we know what it's going to flow. It's going to be on that curve, no matter what, right? Unless it's totally worn out. So we give it, 5% here and there, generally speaking, but it's going to be right on that curve. So 100 gallons a minute at, 1800 RPM. So if we know we're running at, let's say 60 hertz, 30 hertz, 900 RPM, what's our flow? So it's going to be half of that, right? So 50 gallons a minute. So yeah, we'll get into that. You could put a reflective piece of tape on, say, the plug-in shaft where the packing and mechanical seal is, and get you an IR RPM gauge and check the RPM. If the pump's running 150 RPM, then we should know exactly what we're going to flow. So that's one of the nice features, especially if we're feeding chemical, we're feeding a belt press, and of course we can pump the cake on the other side too. But yeah, it's good to know that. Last, not least, one of the most important things, really the only thing that gets put on the list for at least annually, is check the gearbox oil. There's really not a whole lot of maintenance involved with the PC pump. And we've even made it easier with this piece of equipment here. It's the only adjustable pump on the market. But gearbox oil, check your amperage, check your load, check your flow. But so gearbox, you may have different capacities, even though the gearbox is exactly the same. And I'm going to get into that right here. It's pretty important.
Once we open this up, you guys will see how simple this is too. It's literally a rotor that's going to rotate on a stator. And as it rotates, it forces the liquid to take the path of least resistance, so it only has one way to go. When we open it up, it'll make a lot more sense. You guys will see it's literally just a helix that's rotating in like this. It's making it so the liquid has to go in one direction.
It actually gets pulled into one of the cavities, and then it pushes it out the other side of the pump. So, we can pump whole strawberries with that technology and not damage them. It's great for polymer.
Yeah, a lot of industrial applications. We do use like soap facilities, for example. Anything that's really viscous, thick is specifically made for these kind of applications.
So standard configuration here. We've got a vent on top of the gearbox. So M1. And then we have a drain. So oil plug, vent, oil level. So notice your oil capacity on this M1 is going to be less than half of the case, right? So if we invert that, say M4, because this pump can run forward, reverse, it can be mounted on the wall vertically, horizontally. It comes with a base plate, I believe, standard. You can just drop it on the floor, anchor it to the floor. But the PC pump doesn't care how it's orientated. So, we make skids that go onto the walls or whatever. So maybe the gearbox is in M4. So now the vent is going to be moved at the top, and instead of using half, we're going to need enough oil to come all the way up to here. So basically we're trying to wet that ring gear. Everybody has an idea, especially the car guys in here. The ring gear has to be wetted. So as long as we get the pinion and the ring gear, we're good. Now, if the pinion is this way, we've got to bring that capacity up to wet those gears there.
Yeah, what Jason's getting at here is we can configure it basically any way you want it. If you've got an existing setup that's goofy and for whatever reason you want to mimic that again, we have no issue with configuring it however you would like it to be set up. It's all about how the customer wants it at the end of the day. So that's what Jason's trying to show here.
So overall, grease the motor bearings if applicable. Replace the gearbox oil, maybe even take samples of gearbox oil if it's every 3 years, every 6,000 hours. Check shaft runout. Does everybody know what that means? Basically, you have the drive end, then you have the sealing, they call it the lantern or the coupling, and then we have the wet end. The wet end of the pump does the work. So where the mechanical seal is placed or the packing is on the plug-in shaft, you may have to put a dial indicator on there, and just make sure that that shaft, doesn't have a lot of play, because especially with the mechanical seal, we want to keep them pretty concentric. We'll allow maybe 0.003 on the indicator for run out. Anything beyond that, you're out of tolerance, right? So we want to make sure we're within tolerance there. And let's see here. Shaft run out, clean the fan shroud. Obviously, if it's packed with trash, fibers, whatever is flying around, the motor can't be efficiently cooled. Replace the vents. We saw the vents on the gearbox. It's basically a little check valve, a ball check with a spring. Believe it or not, if you haven't run the pump more than its rated capacity, the gear oil never really gets warm, and the ball check will actually stick. So when we change our oil, let's at least check the vent or replace the vent. We can definitely ship you one if you can't find one. Yeah, we can provide that support for you. Test drive unit unloaded before reassembly. So that's something that we do at the shop, just to make sure that we don't have any weird noises, make sure we can isolate everything. So we manufacture these pumps north of Dayton, Ohio. We'll assemble everything. Actually, first, after the materials are made, they go through a rigorously QC checklist, and then our assembly team builds them just like a normal factory. Then on down the line, there's different size test benches, so every pump goes through at least a minimum 2-point, basically half-hour run test, and it has to pass. If it passes, then it gets cleaned up, gets painted, whatever color, usually blue, and then we'll box it out.
He's making that sound very simple. I've been to a lot of manufacturing facilities, and they go through extreme measures on every single one of these. And if for whatever reason the pump does not perform to the way you want it to, they will fix it at their cost for free to you, because they take that much pride in their pump working. It's pretty amazing. If you guys get the chance to go out there, like you said, it's in Ohio as well. It's just a couple states over. Jason's from Ohio. We won't hold that against him. But it's pretty cool. They
Yeah,
take
we
a
do
lot of pride in their
tours.
stuff, so.
Tours and stuff like that. But yeah, I mean, basically you have a packet of tests. It's not, even though this looks, like a simple worm gear, screw type pump, it's a very simple machine. There's a lot of stuff that goes involved. We offer, 3 and 5 year warranties, and we can't just throw something out there, right? And the pump should last 20 or 30 years. You guys, some of you are actually familiar with this type of technology. It does last a long time. Yes, sir. Yeah, so that is
Repeat his question for YouTube.
That is the only Achilles heel that I know of with these pumps is the smaller the pump, the faster that run dry damage can occur, because you have a alloy and an elastomer, basically a rubber and a steel, which may be tungsten carbide, ductile. We're not going to get into all that. But yeah, if we don't have any product and we don't have anything lubricating, then there's a potential for it to run dry. And how long does that take? It all depends. RPM, what are we pumping? Polymer, I mean, yeah, you can run dry with polymer and be fine 10 minutes later, because that polymer's not going anywhere. It's going to stay just like crude oil. The viscosity is up there, the centipoise is up there. But if we're pumping battery acid, denatured alcohol, stuff like that, I mean, it could happen pretty quick. So to mitigate that, basically what we'll do is we have several different options, right? We can connect this to SCADA. We can look at a downstream flow meter, turn it on. If we don't see flow in, say, 5 seconds, we shut it off. If we're doing a suction lift, how long does it take to pull, say, 28 feet? Let's give it 20 seconds or 40 seconds. If we don't see flow in 40 seconds, we shut it off. So that's one way to do it. However, flow meters are very expensive. Some plants don't have it in the budget. And why do you need a flow meter for a WAS or a TWAS pump, right? So what we'll do is for an adder, we'll drill and put a PT100 or a simple 2-wire or 3-wire or 4 to 20 sensor in here, NTC, and we'll measure some temperature. So we'll take a delta, we'll say ambient temperature today is 60. What's the hottest it's ever been in Peoria? Say 110. Okay, so we know the elastomer melts at 270, so let's set it about 150. So when this comes up to about 150, it shuts off. All right, so it basically just has a little contact. You can bring that right back to the variable frequency drive. You can bring that back to SCADA for an alarm. So there's different ways to mitigate the run dry. There's best practices that also need to be followed. Like we don't want to lift aqueous ammonia, sodium hypochlorite, something that off gases. But yeah, if you're just using this for a sludge pump, centrifuge feed, belt press feed, it's a good technology for that. And it's flooded suction. We wouldn't have to worry about that. Now, if we're pulling a digester down every couple of years to clean it out, we need to be aware that, hey, once it gets down to a certain level, let's keep an eye on it. Maybe I've even seen the plant do this, giant pump, keep his hand on it. It starts feeling warm, shut it off. So yeah, good point.
Jason was obviously a service technician in his past life, so he knows a thing or two about working on these pumps, installing them. If you guys couldn't tell already, he's very well versed in the technology. So if you guys have questions in the field, he's probably one of the best people to talk to. So yeah, he's a good ally to have.
Yeah, I worked for City of Westminster in Colorado. Started out as a utility, digging ditches. Went over to the raw water side and made it to plant electrician, which is city electrician basically. Anything that the utility didn't cover, we covered, 4160 and below, which included generator checks, plant upgrades, MCC upgrades. We went from radio to fiber. I was involved in that. Went over to the wastewater side after that. Got to learn about PC pumps, belt presses, and the bugs and all the chemistry on that side of it. So yeah, I've got a little bit of a diverse background. Started out in plastics. But yeah, we can talk about that some other day. But no, this is great stuff, and it's very important. So until 2000, 2001, when I got into water and wastewater, I was in plastics, right? It was a fun job, but it wasn't important. Water is very, very important, right? So that, that makes you want to get up in the morning and go do a great job because people depend on you, right? So yeah, so it's pretty cool stuff. Gets me excited. So yeah, here's the internal workings of a standard PC pump. Not just this brand, but it's pretty common across all brands. You've got a drive. There is no motor here, but you do have a gearbox. There's a splash ring, if you can see here as we work forward. Splash ring, basically if this wetted area packing gives out, it's not going to spray into that lip seal and help to mitigate damage if there was a failure. So we've got our drive end, we've got our coupling, which is what CPEX calls the lantern, and that is what houses the seal, mechanical seal, packing, whatever it may be. This is not an NS pump, it's a direct coupled, so this is coupled to here, and the casing is coupled directly to the wet end. So in the casing area, again, this can be influent or effluent, suction, discharge. The pump can run either way. Here's our pin joint, here's our lifetime seal. If you do have solids and you are rebuilding joints, I highly recommend, say, we're pumping a lot of asphalt, or muscle shells, or struvite issues, or whatever issue you may have, we'll try to, mitigate that damage. And this is a 2-piece clamshell, stainless steel. It's very successful in keeping those boots from becoming damaged. I've seen 2x4s go through our pumps, so we just put that on the downstream side, try to help mitigate that. And here you can see, we make these pumps. There are so many different configurations. That's why you can't just call us, maybe even another manufacturer, and say, I need this size, because we pump everything. We pump everything, right? Yogurt, water, crude oil, chickens, you name it, we pump it. So this can be stainless steel, it may be ductile, it may be API, it may be all poly, maybe all plastic. I mean, I've seen that. Stators, I've seen solid stainless steel stators, no elastomer at all, pumping peanut butter. So ductile, Viton, the list goes on and on. Paint configurations, macropoxies, it goes on and on because it's made for a certain environment. So municipal, and this side of the world, it's pretty awesome, right? Because we only have a couple things. When we pump ferric, that's going to be, a pretty good one. We're going to make sure our materials are going to be correct. But sludge, overall, polymer, piece of cake.
Yeah, this thing excels very highly in the municipal wastewater market because the other stuff that's meant to pump is, how do I say it? The stuff it's doing in the municipal wastewater world is peanuts, no pun intended,
nowhere
compared
near
to the stuff
aggressive.
it's doing on the industrial side. This thing works really well. When I was talking about earlier, it's a very complex unit, but it's a very simple setup. It really is. This is the stator I was talking about, and all it does is rotate on that rubber part. And as it rotates, it forces the liquid to the way it has to go. All these parts here, that's it. There's no crazy hidden parts or nothing like that. Very simple.
Yep, and just to kind of allude to where we're getting into, we're just kind of building it up, letting everybody know that there's different pump configurations, there's different applications for these pumps. And you see the construction of this pump, it has some tie rods, and then we have a solid stator here. There's your solid stator. It's basically a pipe tube, knurled, machined edges, and elastomer that has been bonded or extruded to the inside of it.
I know it's kind of hard to see. We'll change the camera here in a second, but there is
a rotor and stator.
Both sides there.
So next, just kind of going into this is what it is, right? So if this piece fails, it's pretty heavy. It's kind of expensive. It can't necessarily be recycled, right? Because it's a piece of steel. You got to get the rubber out of it. So there's some things to think about when we talk about the SCT. Rotors, if you do have a catastrophic failure, one thing that I don't think a lot of plants know about is we can send you an entire assembled unit. Say that there was a construction project, they dumped a bunch of concrete down the hopper or whatever it may be, and it tore the pump up. Well, we'll work with you and we'll pre-assemble what we can so you can drop it in place, within a half hour to an hour, be back up and running. So rotor stator geometry and animation. I like animations. I put a couple of them in here. It kind of helps me know and help me relay the message of what is happening inside this pump. So as one cavity is opening, the other one is closing. So that provides laminar flow, right? We don't need any check valves per se. We don't need any check valves, pulsation dampeners. So a little micrometering pump that microdoses pack or something. There's different technologies, maybe a hose pump or something, right? Well, if something happens with that, what happens to the chemical? It could fall on the floor because the hose leaks, and then you have these check valves and all this other. This pump will pump laminar pulsation free to an extent, 2,200 gallons a minute down to 0.53 gallons per hour up to 700 psi. So there's some good applications. So uninterrupted continuous flow here, single helice rotor, double helice stator. There's our cavity. And as it turns, that cavity will actually stay open throughout this 360-degree rotation.
Questions? Everybody good?
Good for right now?
Okay.
Hopefully.
Couple more slides and then we'll get this open if you guys want to kind of put your hands on and rotate it, see how it functions, all that good stuff.
Yeah, so why does the pump wear? Single helix rotor, double helix stator, like the gentleman said. It can run dry. It's basically the stator is the tire, the rotor is the road. It's going to wear eventually, depending on how aggressive, right? So if we are, doing burnouts or drifting in the parking lot, we're going to go through tires pretty quick. Just like, hey, if we have struvite or asphalt or how aggressive. If we burn through the stator pretty quick, we need to switch elastomer, right? Maybe we need to go to urethane. We're not here to make money off of parts, right? We want to make sure you have a successful, reliable machine, a PC pump. So we're, so many different elastomers, so many different coatings and different alloys for the rotor. We want it to last a long, long time. Compression fit. So we do require slightly higher torque to get our pump up and running because we use a tighter fit. So if you take one PC pump that has a 7.5 horsepower motor and then we're recommending a 10 horsepower motor, that's one of the reasons is because one, we want to have enough power, more than enough power. We don't want to be right on the edge, and we don't want to have VFD problems or tripping breakers. Another thing is that the pumps are a little bit tighter. Not by much, 20 thousandths rotor stator, so generally speaking 15, 18. So 3 to 5 thousandths tighter, but hey, our pump would last this much longer now that we made it a little bit tighter, right? And we can handle higher pressures with less stages. That is a single stage pump. Stages meaning a full set of cavities, centrifugally speaking, if you put them all together. So single stage may be this much and it's good for 80 psi or 100 psi. Two stage, you just make it longer. So now you have twice as many sealing lines that can hold that pressure back. I think what we'll do
Jumping jacks?
is, it is Friday. We'll look at this piece here and kind of talk about the difference between the standard and the conventional. So I think I'm jumping ahead of myself here real quick. So we talked about seals, here we go. So conventional pump maintenance. The conventional pump requires a suction discharge pipework to be removed. And if this is down in a pit, that can be a pain, right? Maybe you only have one maintenance guy today and this pump wore out and it can't wait till tomorrow. One guy is going to have to disconnect all this pipe work, and like I said, that can be heavy. It's going to take some time. It's an arduous job. Could take a couple hours or a couple days. This pump I can rebuild in under an hour, any size, one guy. And just for the stator, without pulling a snap ring to get the rotor out, all I need is adjustable wrench. That's pretty cool. I don't have to disconnect any pipe work.
Yeah, Jason has actually drove up a couple months ago from Ohio and helped me install a pump along I-80 in Oglesby in under 3 hours. Took the old pump out, put the new pump in, up and running.
Tired pump replacement.
In 3 hours. And me and him, I'm not a technician, as you guys can tell. He knows a thing or two about it, but if we could figure it out that quick, you guys can probably do it a lot faster than we can. So
something to think about, let me dive in here, is this is an adjustable PC pump. There are other technologies out there where you take a spacer out, or you have multiple bolts and stuff. This thing can be adjusted on the fly. So if we look up and we're at 68 gallons a minute and we need to be at 75 or 85 gallons a minute, basically you're going to go flat. And make sure we go flat all the way around and watch that flow meter come right back up. Now, if you got a younger guy and he's real go-getter, and he's out there with the ratcheting wrench, he's got the big 24 inch and he's tightening that sucker down, you'll see the flow go up and the flow starts to come back down. Why is that? Any guesses? It could possibly slow the rotation. Say we got a 25 horsepower motor with a 16:1 ratio, right? There you go. So the cavities inside the pump I'm gonna break this open for you real quick. We said we can guarantee flow within about 1%. That's pretty good. So this can actually be over tightened. And that's why one of the things that we want to do when we start up and commission our brand new SCT pump is take amp draw on the motor, make sure that we got a baseline, kind of figure out flow. So these, you keep these for the life of the pump. They don't go anywhere. This is the only part that needs to be replaced. This part can be thrown in the landfill or it can be recycled. I highly recommend we recycle it. This part is a third the weight of a big stator. Just no steel, right? So one guy can carry, a big stator around downstairs and swap them out. So there's your cavities. And as we compress, those cavity sizes are lower or diminished. So now we can't convey as much. So what do we do if we over tighten it? We could probably speed it up to get our flow, but basically we just over tightened it. So how do we know? Well, why, it's not rocket science. So this right here can be tightened down. This is my 3D printed model here. So you see how this is sitting flush? That means I'm out of adjustment. I probably want to order some parts because I've only got a couple weeks, couple months, couple years, and it's no good. So 4 millimeters on this size pump is where we're going to go. We do zip tie a little gauge tool to say, hey, I'm about 4 millimeters. Let's see, it's just dragging. 4 millimeters, that's your factory set point. So if you're lost, go back to factory. If you lose the gauge tool, go grab an Allen wrench. It's got a 3.5 millimeter Allen wrench, 4 millimeter Allen wrench. So yeah, they say it offers twice the lifetime of a standard pump. Honestly, it's almost infinite, right? Until you bottom out. Maybe you're only adjusting it a 0.5 mil each time, every 5 years. Several pumps only been adjusted once in the last 10, 15 years. But yeah, it's pretty awesome. It's a great piece of technology.
It's past the stator around.
Yeah.
It's past the whole unit around if you want to.
Yeah, go ahead. So there is a couple of little pieces. One thing that I will say real quick, what happens if the rotor's warm? I'm sure you've seen maybe some striations in here, or maybe some of the chrome has been taken off. One snap ring, a lock, pull the collar, and then pull this right out just like that. And then there's our thing. So we do put an O-ring, keep trash out of the lock. It's pretty awesome. Yep, 2-piece. So there's the top and here's the bottom.
His question for YouTube is if the stator is in 2 pieces.
And then the stator is in 2 pieces. Even on your 2-stage models, higher pressure models, it's 2 pieces. You can flip the stators either way. You can gain more life that way. If you saw cavitation or dry run's going to happen on the influence side. That's where we're going to run out of material first. So yeah, flip that around. There you go. You get your flow back, at least enough to make it through. So yeah, it's pretty cool. Technology is evolving. You'll see different manufacturers. We've all got a maintain or repair in place technology. I'm a big fan of it. I just want everybody to know about it. If you do have rotary lobes or other technologies out there and maybe you got a poor primary side of the plant, getting a lot of hair, a lot of fibers wrapped around those mechanical seals, or you're just tired of working on them, there's other technologies out there, right? Yep. Okay. Oh, so maybe we should trim that every once in a while. You could trim a lot of things. So I helped a lot of the geeks out on the SCADA side, so you can trend the 4 to 20 part of it. I mean, you know.
Why are you
So,
calling me that? I'm right here.
so we used to call them. So all of us outsiders, we were W or Whiskey 1, Whiskey 3, and all our SCADA guys were Geek 1, Geek 2, Geek 3. So just an inside thing. So yeah, you can trend. So in short, when should you adjust it? So a VFD is going to be programmed to a maximum, right? So 60 hertz, 70 hertz, maybe even 90 hertz. Some of these premium efficiency motors are designed for almost 4,000 RPM. They're designed for a VFD to run at 90 hertz, right? There's a whole, I can explain all that stuff at a different time. So yeah, if we know that, this pump has been running, or it takes 6 hours to transfer, or yeah, I've never heard the pump run like that. Do-do-do-do-do-do. It's usually, nice and quiet and do-do-do-do, so I guess it's up to each plant and each application.
And I would say also, if you're noticing it's, like you said, it's doing the same flow, but it's consistently running at higher hertz now, there's probably, yeah, you can probably, the trend will probably tell you something as well, right?
So trend the hertz or the frequency, the 4 to 20 signal, the flow.
Yeah, sound.
Yeah, I mean, there's several different things you could trend. I mean, you could even trend the RPM on a VFD, get the feedback off of an analog output and get the RPM. I mean, it may say 1750 and, oh, we've never seen it run over 900 and now it's running at 1235 or something. So yeah, it's pretty cool stuff out there. Some flow meters and even overpressure devices such as Ashcroft and Onyx and isolation rings and stuff, they have built-in technologies as well. But I'm probably going off on. Yes, sir.
So I guess the way this looks, you can do all that maintenance without having to remove it.
Absolutely. So that pump right there, those two end adapters or casings, one would be a pressure branch and one would be a suction branch. Those don't move. The only thing that we have to really touch or adjust is these 4 segments, the 2 halves, and the hardware. So yeah, the rest of that part of the pump is maintenance free.
The question for YouTube was if you can replace was it the stator portion at the plant, or if you have to take it out and do the work elsewhere. When we did the replacement in Oglesby, we did all the work right there on the shop floor, right where the pump was installed actually. So there was 2 pumps there, and we were able to do all the work there right in that little corner. So you can do just about anything you want to until you get into the bigger units. You can pretty much do everything right then and there, depending on what needs to be done.
Yeah, so traditionally, you need, say that stator is 30 inches long. You're gonna need 30 inches to get that off the rotor, right? That technology, you don't need that length. And it basically, it comes apart as an exploded view. So working around that piece of machinery, you only need enough room to remove the segment. So no longer do you need a cheater bar and some of these other tools to work on the older conventional style PC pump.
Depending on your safety protocol in your city, it might require you to use certain tools. Everybody's different, but for the most part, everything can be done right then and there. Just depends on, you might not be able to pick up a certain amount of weight, right?
Yep.
So it just all depends.
Yeah, ergonomics, that's a good point. A lot of the plants don't want an operator lifting more than 50 pounds, or even a maintenance guy more than 75 pounds. A big stator, 300, 500, 800 gallons a minute, you're not gonna be able to pick that up. The new technology, 500 gallon a minute stator, let's see, it's 38 pounds for a stator half, and it's good size, But I mean, it's just a piece of Buna, Viton, just depends. But about 40 pounds, that's pretty nice.
Good question, though.
I have a question.
Mm-hmm.
So you have, at our plant, we have a niche.
Yep. Niche and Bueno.
Ran it with a valve closed, so it broke. But it would pump for a while, but the volume went down.
Sure.
So I still don't, so if you were running that pump you had a valve closed, it sucked like the feed side. What are you gonna damage on this?
You could.
Heavier than the niche?
You could possibly damage something with this pump, but part of the whole commissioning is a lot of our guys are electrically inclined. We'll program the VFD or put the heaters in the soft starter right at NEC level. So we're not going to throw 50 amps at a 20 amp motor, right? So when I start that pump up, and I highly recommend that once you get this pump repaired, make sure that the pump will shut down on overcurrent or inrush spike. That will actually catch, if this pump's designed for 200 PSI and it hits up 350 PSI, I guarantee your amperage on your driver's going up, or your motor starter or whatever it is. So there's a correlation for that torque. It's going to be horsepower or amps, right? So that's the first thing that I would do. Will this one handle more pressure, higher capabilities? Yes. And I don't know if I have a picture of it, but the Netch, do you have the maintain in place?
I don't know.
Okay. So they do, Netch has a FSIP type pump, but it uses a 2-piece coupling rod with an Allen bolt. So essentially you've taken my part and made it this big, so it probably snapped or bound up or something happened, right? Mine is full size. All I did was slide a snap ring over it. So nothing in this pump was cut in half other than the stators. So yeah, we don't sacrifice strength and durability for ease of maintenance like some of these other manufacturers do, if that answers your question.
I know we're starting to cut it close on time,
Yeah.
too, so we'll try to wrap up here as soon as we can.
Yep.
But if you need any more information, you can get both of our cards here. Whatever
Yeah,
can help
I'm
out.
familiar with a lot of the technology. Like I said before, I'm not, I work for CPEX now, and Ingersoll Rand, but I've worked with all this other centrifugal flights, you name it, hydraulics. Yeah, and my card's over there. We can definitely talk afterwards. So yeah, getting back into this real quick, I'm going to try and skip through these last few slides. We're looking at about 45 minutes here. So all of these tools are what you would need to work on a standard pump, right? We've got to get these tie rods off. We've got to open up these joints. We can't even change out the rotor unless we break into the joint. Did you notice on that SCT, we didn't even talk about joints, right? Because that rotor comes out of the plug-in shaft. We leave the joints alone. They're going to last 10,000 hours, right?
You can get most of these tools from NASA as well. That's why I recommend going.
So yeah, it can be a pain. I'm just going to step back here. You can see you're going to need a lifting apparatus depending on the size of the pump. I'm not going to go into depth of this whole thing, but you have to slide this off. Oh my gosh, it could take a forklift. It could take a giant come along depending on how many stages. It could be a 4-stage, 500 PSI pump. How long is that rotor? 4 times, right? So it's going to be a bear to get on and get off, right? Joints, here we go. These are a little complicated. A CV joint in the car, AutoZone doesn't want us rebuilding them, right? They send you the whole CV joint, and you got to take the whole thing off and put the whole new CV joint pre-manufactured, pre-assembled into your car, because it takes a little bit of knowledge, right? Some training, yeah, we can do it. I did it. You guys can do it. But why break into that when you can use that technology? If you don't have to, yeah, they should last the life of the pump, or the life of the pump. So yeah, the joint has to be dismantled. You have to have a means of rebuilding it. It can be a pain. So the maintain in place concept, which we talked about, the model that we're passing around, it's ease of maintenance. We're trying to meet stringent specifications for, how much can somebody lift, how much does somebody need to move, or how many operators or maintenance staff does it take to rebuild something? How long does it take to rebuild something? So we're cutting down the time. How much does it cost to rebuild something? We're cutting down how much it costs, right? Not just the return on investment overall, many years and hours to add up. We're talking about a two-piece piece of rubber compared to a stator bonded tube, right? So the cost and all that stuff, the lead time. There are different stages and pressures. So 500 and something gallons a minute, single stage is 60, double stage is 120 PSI. So there are limitations to this style. We have other technologies as well. So yeah, definitely reach out if you're looking at something. SCT does not require rebuilding the joints. How important is that? I put it in every slide from now on, again and again and again. Smart conveying technology. If you have ragging issues, open the pump up. It takes seconds. Open the pump up. What's wrong? Nothing wrong in there. Put it back together. It's got to be something else. Pretty cool stuff. It says you need a certain box end wrench. Again, send the guy downstairs with an adjustable. He'll be just fine.
From NASA.
Yep. Here we go. Environmentally friendly, less waste produced. Only the stator halves are replaced when worn. Easily recycled. Pretty cool stuff.
I know we talked about a lot of here, but this is a very simple unit. It's very complex in the way it operates, but it's very simple at the same time. If you have stuff you're struggling with pumping or other pieces of equipment you're not happy with, this excels in the municipal wastewater market. It really does.
And there's several technologies out there. We're not saying this is the one end-all be-all. This is just one of the things that we chose to present on today for you because we love it a lot. But and we might be biased a little bit, but
You called me a geek, so it's, damage is done.
He's kind of smart. So,
Any questions before we wrap up here? Go ahead.
Where is this built?
Enid, Ohio.
The question was where it was built at, which is just north of Dayton, Ohio, which is actually cool. I went there earlier this year, last year, and the Speedway headquarters, Speedway gas station, is right next to them. And that is one of the biggest headquarters I've ever seen. It's mind-blowing.
Yeah, we highly
really
recommend. We do tours all the time. There's somebody in there. Anytime we go to a plant and we present or we try to solve a problem, I invite 2, 4, 5, 6, 10 guys. Come to it. We have a fully functioning service department, troubleshooting. We pump on site. We'll take your materials. We'll take samples. We'll run tests. We have a lab, and then there's the whole manufacturing facility. So if you haven't been to Jeep or General Motors or Ford, come to CPEX. It's a pretty cool learning experience. We got high school kids, middle schoolers. Yeah, it's nice that something's made in the USA. It's not 100%. We do meet BABA. But we're not going to put a sticker on it if it's not 100%. So as a deal, CPEX many, many years ago, 30, 45 years ago, Uli Seeberger, who has now retired, and Ingersoll Rand has purchased the company. Just a little background. Uli Seeberger, Germany would make the rotors, and then we'd make everything else here. And we'd also make the stators for the rest of the world. So that's still true today. Germany does make the rotors. At least most of them. We do have some local machine shops. But yeah, everything else is made here and you can see it.
So it does meet
It does.
Yeah,
Pennsylvania Steel, BABA, no problems.
Yeah. And if you don't take my word for it, if you want to see their manufacturing facility, like I mentioned earlier, it's top notch. I mean, they take pride in what they do there. Like I said, if something shows up and it's not right and they said it was supposed to be right, they'll fix it for free, regardless of the issue. I don't know anybody else that does that. Whether it's in warranty, out of warranty, they stand by their product, which is huge. Because anybody can sell you something, walk away, and say, call me in 10 years when you need a new one, right? They don't operate like that. So it's pretty respectable. I like it.
We will answer the phone 24/7.
Yeah. What's that? That's right. That's right. I have a plane. We can go there, man.
Yep. Again, thank you to the Greater Peoria Sanitary District.
Yeah, we'll leave some cards here as well if you guys have more information. There's a lot we didn't touch on. They do a lot of stuff here, more than just progressive cavity pumps. So if you guys have questions, want more info, please let me know. Okay. Otherwise,
Appreciate your
thank you very
time.
much.
Thank you, everybody.
We're going to take a short break and set up the next presentation.
Good morning and welcome back, everybody there on YouTube, as well as everybody here locally at GPSD. Scott Tozier, our Southern Illinois circuit rider, one of my counterparts, or excuse me, wastewater tech, not circuit rider, is going to do a presentation on lab procedures that he's initially developed and did for some certifications overview and presented at our conference in Effingham last year. Scott's been with the association about 3 years. Is actually now a Illinois Class A, Class 1 operator, formerly operated plants in the state of New York for his career. Scott?
There we go. Okay. So you'd be asked to have lab books or at least prove that your equipment is saving the info that you need to show that you've calibrated, like your pH meters, DO meters or anything else like that. So we're going to look at analyze immediately parameters. If anybody knows what those are, hopefully you do know what those are. If you don't, your next lab audit, you'll probably learn what they are. pH we'll go over quickly because pretty much everybody knows how to do pH. The main things we'll really want to hit on is TSS and BOD. Those are the major ones I have questions on. And we probably won't get to fecal coliforms, but if we do, we'll look at that as well. So lab books, the big thing is make sure they're solid bound. You don't want your lab books where you can have removable pages, because if I'm coming in there and looking and you could completely remove a page and change that calibration data. So they want to see it as a hard bound. You can buy, what we had is like ledger books for keeping, auditing and stuff like that. Those are great books for keeping, for your lab books. Some of the items that we'd put in there, when you did a pH calibration, incubator temps for BOD, TSS oven temperatures, sample refrigerator if you're keeping samples for any length of time, your balance check, you should be looking at when you do TSS, your balance check, you should have check weights to make sure that your balance is keeping the calibration. And does anybody have any other things that they keep in their lab book? Those are the most of the ones that we did. So these are your analyze immediately parameters. You know, hopefully, you know, there's more larger labs here, so you guys probably know that it goes into more like the class 3 or 4 plants. They're shipping all their samples out. What's happening is a lot of the pH and DO are being done by contract labs, and you're really supposed to be analyzing those temperature, pH, and DO within 15 minutes. If you're getting a lab or IEPA inspection, most of the auditors now are requiring to have at least a DO meter on site to check the DO. Kent and I have seen a ton of violations for DO, and if they had a DO meter on site, it probably would be avoided. So I just visited a facility yesterday that's got under a violation notice for DO, and it was literally they're taking the sample the wrong spot. And I've seen that, Kent and I have seen that multiple times. So buffer calibration, you always, as you can see on the bottom, you always want to go with what the manufacturer suggests. Everybody does that a little bit different. A lot of plants are doing a 3-point calibration with 4, 7, and 10. What we did at my lab was we would calibrate on 4, 10, and check it on 7 to see how the 7 was coming in, and then would have a plus or minus on the 7. So if we'd calibrate on 4 and 10, or 7 for our lab, which we designated had to be plus or minus 0.05 to be acceptable calibration. Also, you want to look at the slope on your meter and see what the manufacturer allows for the change on slope. You should be calibrating before each certified reportable number. I hope most bigger labs do that. Smaller labs, I've seen pH violations, and we asked, you know, when's the last time you guys calibrated a meter, and it was, I don't know. And you see their buffers, and they were like from 4 years ago. So if you're getting violations for pH, that's, you know, you really want to be checking that. You know, the smaller facilities like the lagoons only have 1 to 2 samples per month, so they don't have to calibrate often. But you should be calibrating that meter, because you can have quite a error on pH for sure without calibration. I'm not going to go through pH too quickly unless somebody's got a question on pH calibration. I've got a bunch of cards here. If anybody needs like help with, you know, any of these items, you know, feel free to reach out to Kent or myself, and I can certainly help you with that. Okay, TSS, this is what I want to spend a lot of time in, because like I get all kinds of questions about TSS. So this is some of the required equipment. The one thing I'll point out here is I've seen a lot of people out here get all their filters from USA Blue Book. And those filters, in my opinion, are not the best filters. And the way I can tell that they're not great is a lot of the people are using them when they do their blank on the TSS, which is basically you're running distilled water, 60 mLs, hopefully at least. They're getting a lot of variation on these filters, and I see a lot of people saying, well, how am I getting a negative number on that? Those filters that they have are just very flimsy, and they're not well constructed. They also have what's called a Wattman filter, which is quite a bit better filter in my opinion. It's the ones that we used, you know, for 35 years in my plant. We didn't get anything from USA Blue Book. We got it all from Fisher Scientific, but it was the same Wattman filters. The Wattman filters are quite a bit better. I don't see nearly the variation on the weights that I do with the Blue Book filters. So weighing balance, obviously we want the balance to have a hood on it. Air currents can hugely impact. I had one guy, you know, he was the same thing. Why are my filters getting such a variation? And he had a balance with side sliding doors on it. Well, he was keeping those doors open while he was zeroing his balance. Air current, and his furnace was kicking on, and you could feel the air current in the room. It was like fluctuating all over the place, and I was like, well, you're supposed to keep those sliding doors closed, which we probably all take for granted and think that. But like I said, most of the people I come across, it's like what Joe Bob operator told the next guy, and it's like, well, he never told me that. Well, that's one of the small things, you know. Vacuum pump, filtration flask. There's 100 different setups I've seen, especially since I've been out here. You know, the biggest thing with the filtration equipment is being able to get a large enough sample through the filter. So, you know, there's modifications. There's all different sizes of filters that you can get to. There's down, I think, 25 millimeter filters, 47 millimeter. There's up to like 120 something, and they can all be used for TSS filtration. So procedure, I'm gonna kind of whip through this because I feel like most of you mostly probably know how to do it, that you're, you know, since you're here. The one thing I will touch on is sample size. That's one of the other things that a lot of people err on, is they're using, especially for effluent, they're using way too small a sample size. Like what size sample do you guys run for effluent? For effluent? 100. Yeah, so technically, and we'll get into this in the calculation part, if you're running 100 mLs, the lowest number you can report down to is 10. So you really need to bump that up to, in my opinion, like a 500 ml sample. So in that, just by the way the methods is set up, and all this goes back to standard methods. If you want to fall asleep at night, there's a book called Standard Methods for the Examination of Water and Wastewater. Everybody's probably seen that, nobody reads. So all this stuff's in there. And whenever something comes up, like there was something on BOD I'll touch on, I go to standard methods and say, well, where is it in standard methods? If it isn't in standard methods, then it's up to interpretation of what I feel like we need to do. Not like, if it's in standard methods, then it has to be done, okay? Anything outside of standard methods? Yeah, we got a question.
So are you saying, is there, I really don't remember, in standard methods, is there a residual weight that you have to achieve?
Yes, so, and Eddie and I were talking about this. In standard methods, you're supposed to get at least 1.0 milligrams of weight. So if you're weighing in grams, it would be 0.0010 weight on that. If you aren't achieving that, then you have to go to what the default is of the multiplier, okay? So if they're using 500, and they don't get 0.0010 residue on there, then they would report that sample as less than 2.0. And if you look at the results you get from PACE very regularly, BOD, and I'll explain detection limits in BOD and TSS a little more, I very regularly get results from PACE that say for BOD less than 4, or for TSS, you know, less than 4. And, you know, we can do the math for both of those. But so that's technically how you're supposed to report that. And the majority of labs out here are not doing that. And like I said, the only reason I know this is because we have lab audits every 2 years, and they'd say, well, what's your result? And I'd report 0.5 milligrams there. Well, you can't do that. Even if you're running 1,000 mLs through the filter and you don't get 1 milligram, you have to report that as less than 1. Nobody's going to run 1,000 mLs probably through a filter, because it's going to take you quite a while, and nobody wants to hold a graduated cylinder that's yay big. So, anybody else have any questions on that? Because that's like, I see that all the time. People are running 100 and they're getting a negative number, and they'd say, well, how can I get a negative number? It's because, so let me see where we're at here just so I don't jump ahead too much. Okay, so it's more, this is where we're at, determining sample size. Like I said, you want to get at least 0.0010 grams or 1.0 milligrams if you happen to weigh in milligrams, which almost nobody does out here. So if I'm running 100, the multiplier to get to liters is what? 10, right? 100 times 10 is 1,000. We're weighing in milligrams per liter. So if we use only 100, it's only accurate down to 10 milligrams. Well, most people, because they have the 85% removal rule in there, you want to get down to lower than 10. Like I would recommend at least getting down to 4. So if we're getting down to 4, then we'd be using 250 mLs. And if anybody's like confused on this, just slow me down. Ask questions. Don't be afraid to ask questions. Because almost none of the wastewater labs I've seen know anything about detection limits. So, and like I said, if you've got questions on it after this and don't want to slow down the presentation, just, talk to me on the side and say, I don't know what you're talking about. Because, it's very common. But, so, the way, raw for sure, the only way you determine your raw size is how long does it take to go through that filtration filter. A very common number is 50 mLs of raw or 25 mLs of raw. And that really, detection limit, because raw always has over 1 milligram of sample on there, it's usually never an issue. So as far as raw, how I determine sample size, I would say try 25. If 25 goes through quickly, try 50. Anytime you're using more sample and have less of a multiplier, you're going to be more accurate. There's just the matter of, like anything you do in life, anytime you have to do a dilution, anything diluted is less accurate because you have to use the math, which is the multiplier. So effluent, most of you guys are activated sludge plants, right? There might be a couple lagoons out here that do samples, but they're very few and far between. Usually it's activated sludge. You're producing water of like 2 to 5 milligrams of effluent. That water will go through a filter super quick. So 100 mLs will go through in seconds. So you really need to bump up that sample size to be able to get more, less of a multiplier, more of a sample. So, did you have a question? No? Okay. Okay, so obviously our drying oven, hopefully we all know 103 to 105 for 1 hour. I've also seen out here where there's some interpretation of this, and once again, I went to standard methods. I do not see this, where people are running their sample in the afternoon, they're putting it in the oven overnight, drying it, and then weighing it the next day, and they said, oh yeah, that's acceptable. I'm like, well, where is that in standard methods? Because standard method says we dry for 1 hour, we put it in the desiccator, let it cool for 1 hour, and if you're technically doing it right, you should repeat that process until you have less than, I forget what the acceptable level is. Nobody ever does that. Our lab inspector wanted us at least to periodically to do that, because she asked, I hadn't been asked about the dry and reweigh cycle, and if you go to standard methods, it's in there. Like I said, I think it's, if your blank sample, which is the 60 mLs of distilled water, is going through there and you're not getting a lot of variation in that filter, then the dry and reweigh, in my opinion, is like, we're really splitting hairs there. But it wouldn't be a bad idea once in a while to show that you do that. And what we came up with, our lab inspector, was when she asked me to do that, I said, do you really want me to do that? Because you know it's not going to be less than what we said is acceptable, is 0.0005 or half a milligram change. That's what our lab says was acceptable. When I asked them what's the acceptable change, she said you have to determine that. There's no number, actually. You just have to say all of our samples normally are under an acceptable level, and that's what we decided. which, you know, in my opinion, 0.0005 is, you know, a pretty large amount of change. So, desiccator 1 hour, repeat. As I was saying, what we decided to do was once a month we would do the dry and reweigh, and I only did it one time. They never had any problem with that. There's desiccator, the number one thing. You know, anybody that has a lagoon inspection, the first thing the inspector goes out there and looks at, and the first thing they're going to look at, are all the banks maintained? Are they clean? If I walk into the lab, the first thing I'm going to look at to see how good your lab is that desiccant blue? It's the easiest thing to look at. If I go in there and I see that's purple, it's spent. You have to dry it. You have to get new stuff. If you want to save money, you can dry that desiccant. It won't come back completely blue. It'll come back some shade of bluish to purple. What I tell people to do is mix some of the new stuff in there, so it's kind of an indicator if the old stuff is spent. If you have a decent lab budget, just replace it. I mean, if I walked into the lab and that's purple, the first thing right away I'm thinking, well, you know, it just gives me a bad vibe, you know, of how you guys are keeping it up, especially if I know there's a lab inspection or somebody coming in to look at my lab. That's the first thing I look at. Because if that desiccant's spent, just the humidity being reabsorbed by that filter and that sample can give you a falsely high number. So, I don't know, did you guys have an electric desiccator? Yeah, so they have an electric desiccator, and Tilton has one and Macomb has one. I've never actually used one. Does yours have like a pillow in there that has a indicator of if it's okay or not?
Yeah, I think it's on the side.
Okay. Yeah. I couldn't remember if this was yours or if it was Beardstown. Normally they have a little pillow in there that has a blue or purple indicator on there to make sure that that's operating properly. I don't know how much they run, but I think it's probably a good idea. Then you don't have to worry about the desiccant. So calculation. There's two ways to do this. You can either be in milligrams or you can be in grams. Almost everybody I see out here is in grams. Grams is the way I originally was taught to do the test. After being an operator for years and years and years, we switched to milligrams because it was easier for me to explain the test to guys that were coming in and train them if we were already in milligrams, and all we had to do is convert to from milliliters to liters. So it was easier, and I felt like it's much easier to say 1.00 milligrams than it is to say 0.0010. That just, even me trying to say that to you guys is like hard to fathom like what that number means. So when I say, hey, we've got to have at least 1.0 milligrams of residue to be able to use that as a reportable number, it's a lot easier for you to visualize, okay, 1 milligram than 0.0010 then. So that's why I switched to milligrams. And probably all your scales, you can switch from grams to milligrams. The only difference is, instead of when you do your calculation, doing a final weight minus the initial weight, instead of being times 1,000,000, which is 1,000 times 1,000, you'd be final minus initial times 1,000 if you're weighing milligrams. So all you have to do is convert from milliliters to liter, and then divide by your sample size. So, any questions? I had a lot more questions last week.
Why didn't you want to let the filter dry overnight? I know that's not the standard method.
Yeah, it's not in standard methods. Do I think it makes a bit of difference? I don't. But like for day to day, I mean, it all comes down to reportable numbers, okay? So, and I don't know if anybody's read that fine print, like on the bottom of your DMR, says, to the best of my knowledge, this is true and accurate, and everything I know is. So when I know something and I know better, most of us as operators, we try to do the best job we can, right? If it's the only opportunity that you have because you're doing 50 different things, Do I think it makes a bit of difference? I don't think it makes a bit of difference, but the test method in standard method says dry 1 hour, cool, or desiccator for 1 hour, weigh. But I realized I was an operator of a 1 MGD plant. I had 2 operators. We checked lift stations. I had a compost facility. I had 50 things going. So did everything get checked exactly 1 hour? Probably not.
So are you using the most current standard methods? 'Cause I'm sure, the reason I asked, I'm sure Eric and I just looked this up and it said at least 1 hour.
Yeah.
At least 1 hour.
At least 1 hour.
Yeah, they're saying they want that crucible to be up to 105 for an hour, is basically what it is.
That's why.
Okay. So
But what
Yeah,
I'm
it's-
wondering is if maybe in a past standard method it did say 1 hour.
I don't see, that method really has not changed in a long time. At least 1 hour is still and you know, Paul probably knows, like everything you read has an interpretation. And what, you know, I won't say like that's the gospel, at least 1 hour. That doesn't mean 24 hours, right?
Well, it means at least 1 hour because it has to be in the oven at least 1 hour to dry completely.
Okay, so if you say at least 1 hour, then if you do leave it overnight, are you going to dry and reweigh it at least 1 hour again? Because you're supposed to.
What do you mean?
So in standard methods, it says you're supposed to dry for at least 1 hour and then cool,
For at least 1 hour.
right, and then weigh and then repeat that process. So if you're saying, you're taking the liberty to say, okay, I'm going to let that go overnight,
Yeah, because it's at least 1 hour. That's my argument.
right.
We have actually left them in for days.
And
Sometimes a
like
Friday
I said,
on Monday.
yeah, like I said, that's, if your inspector says that, okay, that's fine. Let it, whatever. I'm not telling you, that's my interpretation and that's my inspector's interpretation of what you should do. If you say, hey, that's how we do it, and you've shown, you know, we don't get any different results, feel free to do it however you want to do it. Like I said, I understand a guy that might have 50 different responsibilities, you know, do it that way. But once in a while, you should dry and reweigh and say, okay, does that make a difference, or does it make a difference if you're doing it hour in, hour out, you know, so.
So I completely agree with that statement.
Yeah.
So at PDC, what we did there, what we were required to do is we had to weigh it at X time, and then you had to reweigh it at another X time. I don't remember what the difference was before you could actually record.
Yeah. Like I said, I've learned, I had 35 years of this, and I thought I knew a lot about lab. And I talked to 3 different certified labs in my area because we were all inspected, and we always were keeping in communication to see, well, what are they this year looking at? Because every year they'd inspect, they had something new that was like not really new, but that's what they're keying in on. And I've learned more in 2 years being with IRWA, learning from labs. You know, I went to these guys, learn something. I went to Beardstown, learn something. You know, I could go to Galesburg and be like, wow, this is something different. And it's within, you know, there's 50 ways to skin a cat. It's not necessarily wrong. And if, you know, IEPA is fine with it, run with it. If it works for you, run with it. And you think you get good results. I mean, how are your blanks coming out?
Our links are fine. So that's not, my problem is not that. My problem is that the method says at least 1 hour.
Yeah, so,
If you leave it in there longer than an hour, you're okay by method.
yeah, I agree, but the blank would be my indication of, is that okay? Because if the blank is varying a lot with you doing that, then I would, you know, say, well, maybe that's not the best way. But if your blanks are, like, what, have you determined what your variance on your blank is acceptable? Yeah, so, like, I would, if it was me, I would come up with what you feel is a repeatable number on your blank, and then try it both ways, do it 1 hour, and then cool 1 hour, and then try it wherever your normal way is. If it doesn't come up with any variance, then I feel it's fine. And I would be surprised with IEPA and how they're doing lab audits on wastewater that they'd probably have any difference. I think what the very, like the misinformation maybe, in my opinion, is probably the total solids test. being morphed with TSS. Because in total solids test, when you're doing a sludge sample, obviously you have to dry that overnight or you're not going to get it dry. So I think that's probably that's where it came from. But, you know, like I said, I would never say you're doing it wrong. I would say, show me your blanks stable. Maybe, do you do duplicates at all? Yeah. So if your duplicates are coming out good with less than 10%, and your blanks coming out good, then I'd have a hard time being a lab inspector saying you've got to do it this way. So, like I said, some of this is the way I was taught, the way I was inspected, and you know, I've very rarely come in. There's very few things I come into the lab and say you can't do that. So, but any other questions on that? So this is calculation. You know, we already kind of went over this is McComb's bench sheet. One thing that they do, which I'd like to throw out there for discussion, whatever their variance is on their blank, they subtract or add that into their weight of their sample. Was that something you guys do? No. Most labs don't do that. That's the first time I've seen that. Makes sense to me. I don't see that in standard methods anywhere, but it's interesting. I think it's very, like, I found it very interesting. I think it could be very viable, but you know, it's not in standard methods, but they're the first ones I've seen doing that. Once again, like, I wouldn't say, hey, that's wrong. It's different, so. Anybody else out there do that or anything different? No?
Do you do that with your BOD also?
Well, BOD, yeah, if it's, I mean, yeah, if it's,
You subtract out your 5-day blank change?
yeah, if it.
Yeah, I've seen people do that. We'll get into that discussion too. And I've seen that too. So and you'll see that discussion because like I had one lab that's struggling to get their DMR QAs to come out and they had 5-day depletions of 1.5. Like, I gotta draw the line there and say
This is very tiny.
yeah, right. So, any other questions on TSS? Okay, BOD. I swear BODs in my 35 years were more like voodoo than it was actually testing. And anybody that's done BODs long enough probably understands what I'm talking about. BODs, sometimes they just go off the rails and you're like sitting there wondering what happened because like I'm not doing anything different. I'm cleaning my bottles the same way. I'm doing everything the same way. And all of a sudden, you know, my test results are kind of like my 5 days are creeping up or, you know, there's other checks as well. The big drawback to BOD, everybody knows it takes 5 days later to, you know, get the results. So that's what happened 5 days ago. Hopefully all your plants are running good enough that it really doesn't matter. They're putting out good water every day. So DO meters, anybody that's not aware, the DO meters and probes have come a long way in the last 10, 15, 20 years. There's what's called thermoluminescent technology, which I'm sure all you guys are probably using. I've been using it for like almost the first year that came out. We started using it in New York, and we had to prove it was as good or better than the membrane technology that was accepted. It was really evident right away that technology is far superior than the old membrane technology. You can put a new cap on there, put a new probe in service and have accurate results like quickly. And anybody that's run the old membrane DO meters remembers it's just a total hassle. You have to put a new membrane on and it takes a while for it to settle out. So is anybody still using the old membrane DO meters? I bet you're happy about it too. So yeah, I can remember years ago, we had all these bottles and we went to run off our DOs and we had to put a new membrane on and basically that whole day it wasn't gonna settle out and it wouldn't give me good results. So has anybody heard of a Winkler DO titration? Yeah, do you?
I've heard of it, but I've never done it.
Yeah, so basically with a Winkler, you add 2 different reagents, invert the bottle, it'll turn like a yellowish color. It'll settle out. It's a very long process, and you have to titrate every single sample. So it took basically the whole afternoon to titrate all those samples out, and it was like, you got to be kidding me. So as soon as I heard about that newer technology, I was kind of jumping on that. So incubator, 20 degrees Celsius, plus or minus 1 degree. Lab water, something I didn't know, which made sense to me, is people use just store-bought distilled water, which kind of baffled me because, like, I never even thought of doing that. We started out with a still for doing distilled water, and those numbers were up and down and up and down. We ended up buying a reverse osmosis water system just to get our lab water, which was like $8,000 back in 2000, so it was a lot of money. Just to get stable lab water. I wish I would have even thought that, like, you could just go grab distilled water off the shelf and say, hey, let's use this. And actually, most of it is pretty good. Is that what you guys use, or?
We have our own still.
You have your own still. What do you guys use? Yeah, so most of the labs in the state are just using store-bought distilled water, which was like, wow. I wish I would have tried that 20 years ago, because I was like, we could have saved a lot of money and been just, like, if you get a good source of distilled water, like, that's great. And some people, they add their nutrient pills right in the jug, so like, you don't even have to worry about cleaning your carboy. You just mix that up and use that and throw it away, and wow. I mean, my lab, we always struggled getting 0.2 less on our 5-day blanks. They were always kind of 0.2, 0.3 just all the time, and it could never really pin it on anything in particular. It was just kind of always floating around being there. So BOD bottles, does anybody use disposables? You guys? You do? Yeah, that's another thing I wish I would have like thought of like 20 years ago, because that would have been one of the things. We always thought like the part of the problem on the 5-day depletion was possibly the cleaning method. You know, we tried Alkanox, we tried Clorox, we tried sulfuric acid. Everything was always just kind of mediocre, never really good. So I wish I would have thought to use disposable bottles. You know, we didn't have a very, you know, tight lab budget, so we probably could have justified that. The first time I saw that was at Beardstown, and every single bottle, every single test is a new bottle. I'm like, wow, okay. That would have been at least fun to try to see if that fixed the problem, you know. Do you guys have problems with meeting 0.2 on the 5-day?
We don't typically.
No.
Interesting that you say that, though. The whole reason we switched to store-bought distilled water was because of our blanks and our water system that we had at the time in the lab. That's where we traced the problem to that. So
Yeah.
we switched to
Yeah, distilled water stills are very, very hit and miss where they produce good water or not. So it's really can pull your hair out. What do you guys, what are you using, just a still, or are you using RO, or?
Well, I mean, city water has RO, of course, but
Yeah.
it's just a still that we have set up in there, yeah.
Yeah. And any issues with the 0.2? No, that's great. Like, I tell you, I struggle more with that, meeting that, you know.
The only problem we've ever found with using our own still is most recently with DMR QA, mixing up the dilute, you know, for doing the test for ammonia nitrogen. We got 2 failed results, and we're pretty sure it's because it's a copper still. I remember talking to you before.
Okay.
That something with that copper line still messed something up with the QA. Went and bought store-bought distilled water, came out perfect.
Fine,
Exact
yeah.
same.
See, that's why like water stills they're really touchy. I think it's all got to do with, like you said, whatever's in the still, and then the feed water, and just the cleaning of the still. And like I did a still for the first probably 15 years that I was an operator, and I was like, whoa, what is with this thing? You know, we did a conductivity test. I don't know, do you guys ever do a conductivity on? So and that's how and I didn't see that. I don't know if I don't think that's in standard methods, and I believe it's I don't even know what the reading is in conductivity. I think it's like micromos or something like that, 2.0. So you can actually run on your still a conductivity test to see how good that water is, and it was 2.0 mmHOHS or something like that. I don't remember. I'm not a chemist, so. But that's how we could tell, and that conductivity reading was like 1 week good, 1 week bad, and it was really all over the place. So that was a test that you can run if you get a probe, and you can watch your conductivity, and if the conductivity starts going up, then you got to start looking at clean your still, or something's going on. So, but the store-bought distilled water is a great option. I mean, like I said, I wish I would have tried that years ago. So. Nitrification inhibitor and CBOD, not in your raw, but in your effluent. You're supposed to be using nitrification inhibitor. Everybody's doing that, I hope. Dilution water prep. Like I said, some people are doing it in the store-bought. Some people are using carboys to make it up. If you're using a carboy, most people are not cleaning that often enough. How are you guys clean your carboys? Are you? Yeah. How? Yeah. I mean, if you're getting good blank numbers, then do what you're doing. Yeah, I swear, if you're getting good numbers, just go home and thank God, because you're lucky. I did it for a lot of years, and I know the other labs around our area has always kind of struggled with it. And from what I've seen of Illinois, most people struggle getting 0.2. Either that or they're being generous with their numbers. So, nutrients added. BOD, it's one of those things that's kind of like fecals. You just want to be clean with everything. If you're using reusable bottles, glass bottles, just clean. Whether you're using acid or Alkanox. If you're using Alkanox, make sure you rinse, and then rinse with distilled water before you dry them out. This is another thing that I'm not sure people are aware of, because I've seen crazy numbers. You're actually supposed to technically be on your initial DL 9.0 to 7. If you're not, you're supposed to adjust that to make it 9. I've seen some starting numbers of 10s. And there's a method to do that. I'm not going to get into it, because we got not written up, but the auditor came in there and we had some effluent numbers that were 9.5. She says, well, in standard methods it says 9.0 to 7.0 is what you're supposed to be. I was like, well, how do you do that? So there's a way you can adjust that. So anybody else have effluent numbers that can be up there? It's very common with lagoon systems that have algae and I didn't even realize that, because I was at activated sludge plant. The saturation point of air and water, I always assumed it was it couldn't be higher than what the saturation point at that temperature is. Well, if you have algae, it can be ridiculously high and super saturated with air because of the algae. So a lot of lagoon plants, you'll see, will have super high effluent starting numbers. So usually activated sludge plants don't have that high. So, how many people are seeding their effluent? I know you had said that you don't. You guys do? Yeah. So, a lot of people in Illinois don't seed. The only reason I would say you should seed is because your DMR QAs tell you have to seed those tests. So, if you are doing DMR QAs, obviously you want to be in the know how to seed, how to correct for seed, and so forth. So I've got 2 different plants right now that I'm working with on seeding, because one of the guys went to ERTC, and for some reason the instructor said if you're analyzing for CBOD, you have to seed. Right away, when I heard that, I was like, where's standard methods? Because I need to read that, because I do not see that. And I look through standard methods and I don't see that anywhere. And then after kind of talking to Matt Moss, that's apparently his interpretation, but I've never seen that. But if you're not used to seeding and you are running DMR QAs, you need to know how to seed because, like, does everybody know what glucose glutamic acid check is? Do you guys run those? No? Do you? Yes. So you're technically supposed to be running what they call a G&G or glucose glutamic acid check with every batch of samples, technically. Most people don't. They probably don't care out here, I guess. It is a requirement. So you're supposed to be run that with every batch of samples. So what that check is basically sugar water. So if you take sugar water and put it in a sample without any bacteria, you could technically get no depletion, right? Because there's nothing in there to use it. It's the bacteria that use the air, right? So you should be seeding. So if you're running that G&G check, you need to seed that sample as well as your others. And if you're routinely doing that, you should be probably seeding your effluent too, since you've already got to do it for your G&G. And when you get DMRQAs, you have to do it for that, or you could be failing, because they literally, like ERA, or where are you getting your samples from? ERA, yeah, ERA, and I don't know if it's NSA, or there's a couple different. Yeah, there's a couple different providers. They could literally be putting sugar water in that sample. You're analyzing it, getting a falsely low number because you're not seeding it.
Yeah, that's the only time we seed is for DMR.
Yeah.
Or if we do PDCs,
Right. Yeah.
quarterly.
So
What's the purpose of the glutamic? Is it the strength of the seed?
no. So what if you do the G&G or glucose glutamic acid check? You put, I believe it's 150 milligrams or 0.15 grams. Well, that's the amount you put in. But when you, if
98, sorry.
yeah, so if you were making up, we always made it up from scratch. We would buy the reagents. One's dextrose, the other one's glutamic acid. What you do is you take 150 milligrams of each of those powders, you put in 1,000 mLs, mix it, and then you take 6 mLs, put it in each bottle, and when you do the calculation, it should come out to 198 plus or minus 30.5. Don't ask me how they get those numbers, but that's what the,
After 5 days, is you're supposed to?
yeah,
What's the? We buy the little ampules.
yeah, a lot of people do.
Put it in there.
You can do that, yeah.
But what are you checking for? I thought we were just checking for like cleanliness of bottles and all this.
No, you should get a result of 198 plus or minus 30.5 after the 5 days.
Yeah, but are you, for why? Are you checking your distilled?
You're checking your method, you're checking, cleanliness, you're checking, yeah.
Okay.
That's another thing I struggled with too. Like we'd have 50 weeks of our G&G was coming out fine, and all of a sudden it kind of started going off, and like what we pinned it down to, and if you're using the ampules, you're probably way better off, although we never did that. Usually it was those, probably the dextrose or glutamic acid was just getting old, and a lot of times we change it out and it would be okay.
We bought the ampules because when you bought the bigger bottle, you may have cross-contamination with the
Yeah,
pipette, and it would ruin the whole bottle of glutamic acid.
yeah. So you're just taking the vial and put it in the bottle and then diluting it.
And then for those blank BODs, we struggled that last year or 2 years ago, whatever. So we buy dilute or distilled water, but not all distilled water is the same. Found Walmart was better. But the other problem we were having was the temperature. So our initial, when we set them up, if the temperature of the water, the dilution water or distilled water, so we would try to so what we found out was we needed to make sure that our water was the same temperature as like 68 degrees or
Yeah.
20 on the initial BOD, because when you took them out 5 days later, sometimes they'd be just crazy.
Yeah.
And
What?
so I don't know if that was our probe or the temperature on the probe, the thermometer on the probe wasn't working right.
There's
It said it was.
yeah.
It's the meter was the but that's what we found out was throwing off our
Right.
blanks was the water temperature.
What I would recommend is putting your dilution water in your incubator the
Yeah.
day before,
Yeah.
and then that will kind of stabilize the temperature.
Yep.
And your samples, should be bringing up to room temperature before you run your BODs. Most people don't.
Right.
Do you guys do that? Yeah. So that will help with some of that too.
Okay.
So that's one of those things, like, give me a call afterwards. And if anybody's struggling with any of this stuff, like, just get my card and I can come in for a day, or, you know, like Chester, I've been there probably 5 times because he's, you know, there's just different issues there. Like all that training, like I said, is generational. Whatever the guy 3 operators ago said is what they're doing now. And like, people learn new stuff too. Like, it's not always like, well, they were taught wrong. It was just like the knowledge back then now wasn't what it is now. Obviously with the internet and everything else, like, information just flows now. Back in the 50s or 60s or 70s, like, it was whatever somebody told you, you know, so. Samples, cap samples, record them. Does everybody use the caps? I've seen people that don't use caps. So you're supposed to cap them, put a little distilled water over to water seal, then put the cap in. Record your initial DO, put it in the incubator. Incubate 5 days, 19 to 21. You know, technically you should be, like, we record our temperature of our incubator every single day. I would recommend probably at least when you put it in and take it out. Okay, this is another thing that's really been loosely adhered to, is technically to use a sample, you have to get a depletion of 2, which means if you start at a 9, after 5 days you should have a 7 DO. And you need to have at least 1 milligram per liter left over. So if you're not in that range, you are not supposed to use that sample. If that's the only like, some people only run 1 effluent. If you get a number outside of those ranges, you can still use it, but what you're supposed to do on your DMR is qualify, what they call qualifying data, saying that that number didn't meet the parameters of the method and it's basically suspect. So you can still use it, it's just, you know, it's not as accurate as it could be. So if you aren't getting a depletion of 2, you know, you should be either on effluent, you can report it as a less than value, because almost everybody doesn't get a depletion on their effluent, right? I mean, do you guys get a reportable number? Okay, well, some people do, some people don't. Most effluents are reported as less than 4. So, because what they're doing is they use a sample size of 150, and then they dilute it 50-50 with dilution water, so you have a value of a dilution of 2 to 1. And then if you aren't getting 2, then with the math of it, you should be reporting it as less than 4. A lot of people use 250. If you're using 250, you could report it down to less than 250. So I think I go over that a little bit more here, but. So this is a simple math. This is without seeding, because the seeding's a whole, could almost be a whole hour presentation. Like, just trying to teach people how to seed that haven't done it regularly is a lesson in futility almost. I've been back to plants 4 or 5, 6 times just trying to teach seeding, just because, you know, I was always taught to use my raws as seed, and, you know, just trying to determine what the proper seed blank strength is can be very frustrating. Like, I had a plant last week at Pittsfield. They did it the week before. Their flow was really dry. I told them to run 20 and 30 seed blanks to see which one would come out. Well, the first week, neither of them came out. You know, they were both over depleted. And then the following week, they'd gotten 5 inches of rain, and then they didn't have enough depletion. So it was like, so I'm going to look very closely at, like, teaching people polyseed. I have not used polyseed. Do you use polyseed?
I have, and I hate it.
Yeah. Why do you hate it?
It just, every time you make it, it doesn't ever seem to be consistent. Like, it's not consistent over
Really?
time. Like, it just seems like it changes. And then as the seed ages, then that
It changes it.
seed value. I would never use it if I had to.
Really? Huh.
You just have to learn
Yeah, I've seeded for 35 years, so to me, and to teach people, like when we would do a seed blank, we would do a 10x blank. Is that what you do?
We do, what do you know? I can't remember, it's been a while.
Yeah.
30 mils maybe?
And then what do you put it?
Change ours too.
What? Right.
Yeah, so we change ours, so as our raw influent is
Changing, right.
changing
Yep.
our seed.
So I always told my operators that we always were aiming for a final DO of 4 because that kind of gave us leeway either way. If we were getting too much of a depletion, you want to cut your seed blank back. If you're getting too little, you want to increase it. And for us, I never had them change it more than 0.5. So in the 10X, we would either go from 30 to 35 because even with high flows at our plant, it didn't change it a lot. And every time we went by a whole ML or a whole 10 mLs, it was just blown. So. But I mean, if you always do raw and that's the way you're taught, it's not that difficult. But if you're starting from scratch and trying to figure this out, and I'm not actually there to, what I think I need to do is nobody wants to set up very many bottles in these small plants. They're like, wow, we just don't want to, I set up probably 15 bottles every time. So we had our blanks, we had our 10X seed blanks. We did our raw, we would do 369 raw, and then for effluent, we'd do 150, 200, 250, and then our G&G. So we're very used to doing a bunch of bottles, so doing a couple more wasn't a big deal. Well, most people only run one bottle for effluent, which I think is a mistake because if there's a problem with one bottle, you can, kind of have false numbers. But you said you only, when you do your DMR QAs, do you do polyseed or do you do raw?
Yeah, influent.
You use influent, yeah, okay. And that's a whole process too. Like you have to filter it, you have to prep it, you should do it the day before. It's quite a process. So if anybody wants to learn about seeding and how to do that, get a hold of me. So I'm not going to get into fecals. The only thing I'll say about fecals is there's a couple different methods out there. Macomb, some of these pictures are from them. They're doing IDEX Quantitre, which in my opinion is a very easy method. If you're starting from scratch and you say, well, we got to start doing fecals, then you need to look at Quantitre, or at least keep it in the conversation. Are you guys doing Quantitre or are you doing membrane filtration? Yeah, almost everybody's doing membrane filtration. Which is fine. I just find the Quantitre is very easy. There's very little learning how to do it. It's basically add your sample size to your, your agar pillows and then shake it, put it in the tray, seal it, read it off, But it does require special equipment. It requires a sealer, which is not cheap. I think we started up over in Georgetown and they had about $8,000 to $10,000 just in the equipment to start up. So then there is membrane filtration on the bottom. I'm not going to go through that, but this is the chart that you would use to read off the Quantitre. You'd have large cells and small cells. Each one of the ones on the right are large cells, then there's the bottom ones. What's the indicator on the top?
It's a positive indicator.
Just meaning that there is some presence? Yeah, okay. I had a question of that. And so our water plant ran E. coli, which is you can use in Quantitre too. And somebody asked me that the other day, and I'm like, I think it's just an indicator, but I didn't know the answer to that. So.
I think one of the main reasons why is because it's basically a 100 ml sample plus a little bit extra.
So it's when it squeezes out, you have that extra.
Get
Gotcha.
everything in the bottom,
Okay.
small and large wells, and then
Yep.
it goes there.
Yeah, I've seen probably maybe 6 treatment plants that are doing Quantitre. I think it's a great, like I said, if you've already got a water bath, probably your water bath, especially for the small facilities, doesn't fit a Quantitre. So you'd need a new water bath, you'd need a new sealer. So if you're doing membrane filtration and you're happy with it, then you're probably not going to do Quantitre. So wanted to thank Josh and also Wells from Beardstown. He helped a lot with this presentation. We got a lot of pictures from Macomb. I was happy to see they're doing Quantitre because they were the first ones I came to that actually did Quantitre. So, any other questions? Okay, that's all I got.
Thank you very much for tuning in. We had some technical difficulties today. We're going to try to get that fixed for our next meeting. Thank you.